We all know the familiar faces of our solar system, the worlds we grew up with. But there's another side to our solar system we're now discovering. The misfits and oddballs. Worlds of freakish shape and size. Of extreme landscapes. Mysterious phenomena. And hidden secrets. Our neighborhood is far stranger than we ever imagined. So how did all these weird worlds come about? Well, to answer that question, we'll have to explore the force that sculpted and created them, gravity, and the forces that resist its relentless inward pull. And also, at a deeper level, as there's always a deeper level, we'll be forced to contemplate why there is anything of complexity and beauty in our universe at all. Welcome to the solar system of the weird. From a cloud of gas and dust, gravity, the great sculptor of our universe, fashioned our star and all the worlds and moons around it. Creating the solar system. And gravity has continued to shape these myriad worlds ever since. Let me give you a little 30-second lecture on gravity. And I'm going to use Newton's picture, not Einstein's, because we don't need the additional accuracy delivered by relativity. Gravity is a force of attraction between objects, and it only attracts. So that means that it tends to clump things together. And it's a force that only depends on the distance between objects, not the angle. And so it tends to make spheres. It's this property of gravity that shaped the moons and planets. But beyond the near-perfect spheres that dominate our solar system, out past the giant orbs of gas and ice, in a distant realm of the solar system, we found something strange. Only one craft has been sent to explore the worlds of this distant region. And on its epic, ongoing journey, the probe caught a glimpse of something truly bizarre, moving in the dark. Not a sphere like Earth or even Pluto, but a giant 2,000-kilometre long egg-shaped world. Orbiting around it, 2 glittering moons, mountains of icy rock, and a faint ring. If you were standing on Haumea's surface, the stars would wheel above you, 6 times faster than here on Earth. Haumea is a truly unexpected and bizarre-shaped object. The first like it ever discovered. Leaving the question, what created such a seemingly gravity-defying world?
Now, for rocky worlds, the force resisting the inward pull of gravity is created by this, the rigidity of the rock. And the thing about pressure is that it acts equally outwards in all directions. So if you have a force that's squashing everything inwards equally in all directions, and a force that's resisting that squashing equally in all directions, then the shape that's naturally produced is a sphere. You might say, well, why is something like that not a sphere then? I mean, it's made of rock, it's got a gravitational pull, but it's a very weak gravitational pull because it's not very massive. And that's the point. So the gravitational forces on the surface here trying to squash it down are nowhere near big enough to overcome the strength of the rock. So how big does a thing have to be such that the gravitational force is strong enough to overcome the strength of the rock and allow it to deform into a sphere? And you find, if you wave your hands around a bit, that size, the radius, is something like 200, 300 kilometers. It's called a potato radius. And indeed, you find that if you look out into the solar system, anything that's smaller than about a couple of 100 kilometers in radius looks like that. And anything that's bigger than a couple of 100 kilometers in radius looks like the Earth.
From what we observe, it seems that the potato radius is a pretty strictly followed rule. The larger worlds are, the more spherical they become. Yet it's a rule Haumea breaks. Way over the potato radius, Haumea should be a round world. So if its egg shape is not down to its size, then what is it? There is a clue found by looking at our world in a slightly unusual way.
This is a photograph of us working on the beach today. I use the term loosely. And what we did is we took a time lapse, but it's an interesting time lapse. We used an astronomical mount, and so we fixed the camera at a single point in the sky, the sun. And then you see what happens. So it's holding its position. It doesn't look right because the whole ground is rotating around. So usually our experience on the surface of the Earth is watching the sky and the sun and the moon and the stars rotate around us. But if you take that motion out, then what you're seeing here is the Earth rotating beneath the sky.
This unusual view really brings home the fact that we live on a spinning ball of rock.